Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a very interesting exponential equation. We have z at the base, z at the exponent, and we have I on both sides, so on and so forth. It's a good mixture in my opinion. What do you think? Okay, so we're gonna go ahead and solve this problem and also look at some results from Wolfram Alpha, which look just amazing. Anyway, so let's go ahead and use the definition for complex exponentiation. So anytime you have something like z to the power w, where z and w are complex numbers, you can write it as e to the power w ln z. And how do you define ln of a complex number? That's something we're going to need along the way. So let me go ahead and define it. ln z is defined as ln absolute value of z, which is a real log, plus I times the argument of z, which we usually denote by theta. So if you use r for this and theta for that, it's going to look a little nicer. All right, cool. Now we're going to use this definitely, so let's save it and pick it up from here. We have z to the power negative iz, so w in this case happens to be a multiple of z, a complex or imaginary multiple, right? Doesn't matter, we can still do it. So z to the negative iz can be written as e to the power negative iz multiplied by ln z, and per the problem it's equal to I. So think about it for a minute. How could this expression equal I? What could z be, right? Okay, if you didn't come up with something, that's perfectly fine. We're gonna take a look at it. All right, we'll take a deeper look. So first thing I'm gonna do is complexify the right hand side. Well, it's already complex, but I want to use the polar form on I. Okay, so let's go ahead and express I in polar form. If you'll remember the Argand plane, I is going to appear here. That's imaginary, that's real, so on and so forth. But I is just going to be 1 unit from 0, and its modulus is going to be pi over 2. I mean, not the modulus, the argument, of course. But that's just one argument that you can come up with, because we can rotate and rotate and rotate like crazy. Either way, we can basically start here, add 2 pi to it, and that brings us to the exact same point. It's as if adding 0, but we make one rotation. And obviously, when you write it out, it's going to look like pi over 2 plus 2 pi, which is 5 pi over 2. Obviously, numerically, it's different from pi over 2. Make sense? Okay. So there's going to be infinitely many arguments, but let's keep it simple. But first, let's keep it more complicated. So here's what we're going to do. We're going to go ahead and write this as follows. I is e to the power I times pi over 2 plus 2 pi n, where n is an integer, right? That's definitely adding multiples of 2 pi to it, because that's the period. Well, I can go ahead and now set the exponents equal to each other. Negative iz ln z equals I times pi over 2 plus 2 pi n. One of the nicest things about this equation is that I cancels out, so we don't have to worry about it. Get rid of that real quick, and then you can go ahead and multiply both sides by negative 1. That's going to give you z ln z equals negative pi over 2 minus 2 pi n. But notice that n is an integer, so I can easily replace negative n with another integer k and kind of write it in a much better or maybe more standard way. You don't want to subtract. I mean, you can subtract, that's fine, but I don't want to. So allow me to replace negative n with k, or n with negative k. Same thing, right? So we have z ln z equals this. Again, this is still complicated, right? So let's do the following. We're going to look at a special case, can we? Because if you don't, then I'll show you what happens at the end. So wait until the end, and then we'll see what happens. So we're going to look at a special case, which is k equals 0. When k is equal to 0, we get z ln z equals negative pi over 2. You can now write the negative anywhere you want. I like it better in the numerator. Now, next, we'll do some hocus pocus. I mean mathematic. So here's how we can do it. First of all, keep the ln z and write the z as e to the power ln z. Isn't z always equal to e to the ln z, even if z is complex? Yes, I mean, I think so, right? Don't you think? So this is equal to negative pi over 2. Great. So that's a number. We have a constant on the right-hand side. But what do you see on the left-hand side? Let's do some substitution to help you see better. Let's go ahead and call this t. and this becomes e to the power t. So now I have t e to the t. Hello, Lambert. We're going to use your function. Great. So now we have something like this. We can definitely W both sides. Are you familiar with Lambert's W function? If not, go ahead and look it up. It's pretty easy. But basically, Lambert's W function is the inverse of this function right here inside the parentheses, t e to the t. So when I apply it to t e to the t, it just spits out or gives us t. But on the right-hand side, we have something a little ambiguous at this point. But don't worry, we'll fix that too. Okay? So t is equal to w of negative pi over 2. But what is t? T is ln z, because that's what we called it, right? ln z is t, t is ln z. So this becomes ln z equals w of negative pi over 2. Great. Now we want to get to z because we're looking for z, right? I mean, that's what we're trying to solve for, right? But how do you get to z from ln z? Easy. Easy. Z equals e to the ln z. You see? E, z. So now, hopefully that will help you remember. So now z is going to be then e to the power w of negative pi over 2. Awesome. So this is the z value, but the problem is, what is Lambert's w function of negative pi over 2? And then whatever that is, I have to raise it e to the power that. So what is this, right? You're probably wondering. Let's find out. So we're going to start with this. And then we're going to turn it into, again, we'll do a little bit of hocus pocus math magic. Are you ready? Negative pi over 2 can be written as negative 1 times pi over 2. And then negative 1 can be replaced with I squared. I'm like, why would you do something like that, right? Somebody in their right mind wouldn't do that, because why would you replace negative 1 with I squared? Because I need a special product. Bear with me. So now I squared is going to be written as I times I, but I have pi over 2, so it's going to be I times I pi over 2. Does that look familiar? If not, I'll tell you what it is. Okay, this is ln of I. Why? You might be asking, right? Remember, I gave you the definition for the ln of the complex numbers. What was it? Ln absolute value of z times I times ln absolute value of z plus I times argument of z. So ln I would be ln absolute value of I plus I times the argument of I. As you know, the absolute value of I is 1 because it's 1 unit away from 0. So that's ln 1. ln 1 is 0. And argument of I, at least the principal argument, is pi over 2. Wow, that's great. So something worth memorizing, I think. ln I, at least one of the values, because this is multi-valued. Come on, there are infinite many. But one of them is I pi over 2. So I can replace I pi over 2 with ln I. That gives me w of I ln I. Now, allow me to turn this into ln I, right? But why? Think about it, and hopefully you'll get it. If not, comment down below, and I'm pretty sure someone will answer it. But that's something that you should definitely know. So we got ln I on the right-hand side, and which was this. So w of negative pi over 2 is ln I, right? And we have now z equals e to the power w of negative pi over 2, which is e to the power ln I, which is I. And wow, that's amazing, isn't it? Let's go ahead and check it out. We have z to the power negative iz, replace z with I, replace z with I. You get I to the power negative I squared, which is I to the power 1, which is I, case closed. And this brings us to the end of this video. Thank you for watching. Oh, I forgot to show you. Yes, almost forgot to show you. Wolfram Alpha, awesome solutions, right? Yay, beautiful. Okay, anyways, this really brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.